guys, welcome to my channel. In this video, I'll be talking about the types of mapping. The first type of mapping is known as one-to-one mapping. So one of the examples for one-to-one mapping is a linear graph. So let's use the most simple linear graph, which is y equals to x. So this y equals to x graph is a type of one-to-one mapping. So why is it a one-to-one mapping? It is because of one input. For example, x equals to 1 is our input here. And if we draw a vertical straight line, it touches one point of the graph. And from this point of the graph, we read the y value and we see y equals to 1. So y is equals to 1 is because of this graph is y equals to x. That's why the x value will be equals to the y value. So if we continue to extend our x equals to 1 or our y equals to 1, we can see that it will not touch another part of the graph anymore. So therefore, we can conclude that one input has only one output in one-to-one mapping. So we can see here, 1 here represent inputs and 1 represent outputs. So if we take another point on this y equals to x graph, let's take x equals to -1. So we are going to do the same thing where we draw a vertical line. And you can see that it will only touch one part of the graph as well. And we can read this y value, and this is y equals to -1. So therefore, this is a one-to-one mapping. The second type of mapping that we are going to look at is known as many-to-one mapping. So many here refers to the input as well. And for 1, it refers to the output. So that means we expect many different inputs is going to map to one output. So one of the examples we can look at is y equals to x squared. So this is our y equals to x squared graph. And why is it a many-to-one mapping? It's because of if we take an unknown, for example, x equals to a. We take x equals to a as our input, so we can see it touches one point of the graph. And we are going to read the y value for this. So for example, here can be y equals to b. And if we continue to extend y equals to b, we will see that it touches another point on our graph. And from this point, we see another input. So for example, it is x equals to -a. So we can see that in this graph, two different input, x equals to a and x equals to -a, they have the same output. That's why we can conclude that many different inputs, they have the same output. So this is many-to-one mapping. So it's not always that our input must be one negative and one positive. It can be two positive or two negative. But the inputs will be distinct inputs. So let's move on to the third type of mapping. The third type of mapping is known as one-to-many. So once again, this one here represent our input and many represent our outputs. So that means one input will have many different outputs. So one of the example we can look at is our y equals to positive negative third x graph. So this is y equals to positive negative third x. So first, let's try to understand the graph. So if we zoom in a bit and then we focus on this positive negative sign here. So why there is a positive negative sign here? It's because of this represent a combination of both positive third x and negative third x graph. So if we want to look at them individually, it will be like this. So this is positive third x, y equals to positive third x, and this is y equals to negative third x. So you can see if we combine both of this positive and negative third x graph, we are going to have this graph as our final graph. So why is this a one-to-many mapping? It's because of, if let's say we take an input x equals to a, and we are going to draw a vertical straight line, and you can see this vertical straight line x equals to a is touching two different points, and from these two different points we read two different y values, y equals to b and y equals to negative b, for example, where a, b are just any constants. So we can say for this type of mapping, one input has many different outputs. So these are the three types of mapping. So the first type is one-to-one, where it may be a linear graph or it may be an exponential graph, for example. So if we have a graph like this, an exponential graph, so you can see this is a one-to-one mapping as well. So one-to-one mapping is not always only for linear graph. So this is for many-to-one mapping, and then you see it is a quadratic graph, and this is for one-to-many. And now let's look at a few more examples to have a better understanding on the types of mapping. So for example, we have x maps to x squared plus 5, where x is an element of real number. So before we start sketching the graph, let's try to understand this question. So here this represents domain. So the meaning of domain is a set of x values. So we can kind of imagine domain to be a set of x value that restrict our graph. So if we see x is an element of real number, it means that we can have any numbers to be shown on our graph. We just cannot have x to be an imaginary number. So let's draw our graph now. Y equals to x squared plus 5. So actually we can break this graph down into a few different steps. So first we can sketch y equals to x squared, and then we sketch y equals to x squared plus 5. So plus 5 here represent bringing our graph up for 5 levels. Up for 5 levels. So for example, if we have plus 3, it means bring it up 3 levels. If we have minus 2, it means bring it down 2 levels. So we know that y equals to x squared looks like this. This is our basic graph, y equals to x squared, where it intersects at the origin. So if plus 5, y equals to x squared plus 5, then we are going to move our entire graph up for 5 levels. So our final graph will look like this. Intersect at y equals to 5. So if you do not prefer to use this method where we break the graph down into a few steps and then we sketch each of the steps, you can just find the x and y intercept. So you can try to find the y-intercept by substituting x equals to 0. So when you are looking for y-intercept, it's always the same. You substitute x equals to 0. So y equals to 0 squared plus 5. So we have y equals to 5. As for x-intercept, if you try to find the x-intercept by substituting y equals to 0, 0 equals to x squared plus 5. Negative 5 equals to x squared. And to solve for x, we need to square root our negative 5, and we will get positive negative 5. Square root of negative 5 here. And this x here is no real solution, because our answer will be imaginary. Because we know that we cannot square root a negative number. So when we square root a negative number, we get imaginary roots. So no real solution. So when it comes to no real solution for our x-interception, it means that we won't have any x-interception. And first thing is, you need to understand that x squared plus 5 is a curved graph. This is a curved graph. So based on the graph that we have sketched here, this is our y equals to x squared plus 5. So we can now conclude that this is a many-to-one mapping. Because if we try to get an x input, x equals to a, and then we will realize that the y output here, y equals to b, is for two different inputs. So here maybe is x equals to negative a. So let's look at the next example. For the next example, we are going to look at x maps to x squared plus 5, and where x is an element of real number and x must be bigger or equal to 0. So first, let's understand the question. So we already understood what does this mean in our previous question. So this means x is an element of real number. It can be any real number. It can be positive, negative, it can be 0, it can be rational or irrational. What about this? This is also a domain. So both of them, they are domains, because of they are a set of x value that apply restriction to our graph. So x must be bigger or equal to 0. So that means if we sketch it out, this is our y-axis and this is our x-axis. So that means we are only allowed to show this part of the graph, because this part is positive x part and this part is negative x. So we are not allowed to show this part of the graph. So let's sketch this y equals to x squared plus 5. So if you have understood the previous question, y equals to x squared plus 5 is we first sketch y equals to x squared and then bring our graph up 5 levels. So if plus 1 means we bring it up 1 level. So our graph y equals to x squared plus 1 will look like this, intersecting at y equals to 1. But if we look at this question, we have something extra here. We have a domain here. X must be bigger or equals to 0. So just now I mentioned that we cannot show this part of the graph. So that means we are only allowed to show this part of the graph, the highlighted one. So if we apply domain, with domain x must be bigger or equals to 0, our graph, our final graph, would look like this, intersecting at y equals to 1. So based on this final graph, we can now answer our question. This is a 1-to-1 mapping. So I hope these two extra examples are clear enough for you to understand the types of mapping that I have mentioned. So if you have any question, please feel free to comment down below in this video.